Let us find the envelope of the one parameter family of curves for this function here. Erase these things here from before. Yeah, for this function, should look familiar. This is the general equation of a circle. All right, x minus a squared plus y minus a squared. Normally you would have plus y minus b squared, where a would be the offset of the center of the circle in the horizontal direction, and b would be the offset in the vertical direction. But in this case, we need one parameter. That parameter would be a. And then r would be the radius of the circle, right? So you remember that what we have here, these straight lines would be the envelopes. They enclose the curve. They are tangential to the curve. In this case, our curves are circles. There are three. Here are three of them. All right? So let's see how this thing goes. We're going to find the envelope of the one parameter family of curves for this. But let's be reminded though, the steps that we should take when we're doing this kind of thing. Remember, step one, you're going to write the function in the form f of x, y, z, and so on equals 0. That means you know what you need to do to move everything to the left and have equal, then 0 alone on the right hand side. Alright? Then, oh no, why is this thing jumping up and down like this? Then step 2, you F-E-R-E-N-T-I-A, you differentiate the function with respect to the parameter. In this case, our parameter is a, right? And step 3, we're going to do, for step 3, we're going to solve simultaneously and simplify and so on, and make the parameter the subject, right? That means you're going to, when you find out what the derivative is, the derivative of the function, you substitute it here, whatever the derivative, and then you make a the subject, you substitute it there. So you solve simultaneously by the method of substitution. And since this involves circles, you will find later on that you have to do some type of factorization of a quadratic function. Alright? But anyway, let's see how we deal with this. X minus a squared plus y minus a squared equal r squared. So we have x minus a squared, squared is here, squared, plus y minus a squared equals r squared. How does this thing go? Now remember, r squared now is a constant, just that I want it in the form of the general form of the circle. Alright, so we say x minus a squared plus y minus a squared minus r squared equals 0. That's step 1. That's the part where we write everything on the left equals 0 alone on the right. Differentiate with respect to the parameter. So we're going to differentiate with respect to our parameter is a. Alright? So we differentiate partially with respect to a. Now remember, if we differentiate partially with respect to a, we're going to differentiate this part. Use the chain rule. Right? The outside function is all of the square. So the derivative of the outside function is 2. And if you need to, you could say let u be equal to x minus a, and then u, whatever it is by du is 2u, right? And so on and so forth, right? But anyway, I'll assume that you've been practicing the chain rule enough. So with this one, you can do it mentally. But if you need to, you could just use the chain rule, the long method, using u equal x minus a squared and u squared and so on and so forth. But this is 2 times the inside function, which is x minus a to the 2 minus 1, which would be to the power of 1, but you don't need to write it there. And then find the derivative of the inside function, x minus a with respect to a, will be what? Negative 1. See that? And then something similar would happen with the y part. So you plus 2 y minus a, and then times negative 1 here, and then minus 0, because remember r squared is just a constant, and then all of that is equal to 0. Alright? All of that is equal to 0. Now, let's open the bracket. What would happen when we open the bracket here? You have, well, let's put this as negative 2 times what we have there. Alright? So negative 2 times x minus a, just to simplify it, minus 2 times y minus a equals 0. So when you open the bracket, you have negative 2x plus 2a minus 2y plus 2a equals 0. Make sure you're following, you see that? Alright? So now, what we have now, 2a and 2a. So you have negative 2x minus 2y plus 4a equals 0. That's what to that. So what we have is negative 2x plus y. You see that? Factor out the 2, x plus y. They subtract 4a from both sides now. Equal negative 4a. Now when you make a the subject, you're going to put the 4 under here and divide by it. And let's flip it around at the same time. A equal negative 2x plus y over negative 4. So that would amount to what? Negative into negative, positive. So you have x plus y over 2. Alright, nice. You see that? So we have the thing here. The parameter a as the subject, x plus y over 2. Now, let's substitute into, I didn't label it equation 1 or equation 2 or whatever it is. Alright? X minus a squared plus y minus a squared equal r squared. So into x minus a squared plus y minus a squared equals r squared. Alright, so let's do that. So we have x minus x plus y over 2 squared plus y minus x plus y over 2 squared equals r squared, right? Because of course a is the same thing as x plus y over 2. Now how do we deal with this? Alright, it's going to be quite a lot of writing and probably somewhat messy if we square it as it is, so let's not do that. Let's try and simplify what's in the bracket first now. Suppose we multiply, alright, let's use common denominators. Multiply top and bottom by 2. We have 2x over 2. Same thing as x, right? So for this part, we can just say at the top 2 minus, you have to remember the bracket here, 2 minus x plus y over 2. All of that is squared, right? Plus, remember this part is just fractions. Let's put the y over 1 and then multiply top and bottom by 2. Oh, 2x, I should write here. Yeah, 2x minus that. Alright, so this would be 2y minus x plus y all over 2. And all of that squared equals r squared. Right? I use common denominator method here. But I could have drawn the line and find the LCM and so on and so forth. But the common denominator is more fundamental. The drawing the line and finding the LCM comes from the common denominator method, right? But anyway, how would this part go now? You have, well, let's open the brackets. 2x minus x minus y, that's what we would have. Right? We don't need the brackets here. Over 2 r squared. You see that part? Let me rewrite this part. It's kind of messy. This is supposed to be 2x, alright? 2x. Good. Alright. Plus, I open the bracket here. So we have 2y minus x minus y over 2 squared equals r squared. So this simplifies now to 2x minus x is what? X minus y over 2 r squared. Simplifies nicely. Luckily we didn't multiply out the brackets up here because that would be quite messy. A lot of writing and so on. And the fact is you might make mistakes if you did that. But anyway, you say plus 2y minus y is just y. So y minus x over 2 r squared is equal to r squared. So you see that part? Alright. Now, we're going to do square both top and bottom. Remember, something over something else square. You can square the top alone over square the bottom alone. So it's x minus y squared over 2 squared, which is 4, plus y minus x squared over 2 squared, which is 4, equals r squared. Right. Now the thing is, you can just multiply both sides by the 4, you know. You just multiply both sides by the 4. You have x minus y squared plus y minus x squared equals 4r squared. So that's what you have there, right? Now, We want to multiply out the square parts. So let's see. X minus y times x minus y plus y minus x times y minus x equals 4r squared, right? R. Let me write this r properly. All right. So, I run out of scrolling space here. But anyway, let's see what more we can do. So it's x squared minus xy minus xy. That will be minus 2xy plus y squared. Right? Plus, we have y by y squared minus xy again. You have minus 2xy times x, negative x by negative x plus x squared equal 4r squared. So remember, what we want to do is simplify this. See if we can get the envelope. But run out of scrolling space. I can't scroll down anymore, so let's divide the screen and work on this side of the screen. Alright, so we have x squared minus, x squared minus 2xy plus y squared. Let's write that up here. So we have x squared minus 2xy plus y squared. Oh, it's not bother with, we don't need the brackets there. So x squared minus 2xy plus y squared plus y squared minus 2xy plus x squared plus y squared minus 2xy plus y squared equal, and then what we have is 4r squared. Alright, equal 4r squared. Good. Let's simplify this now. We have x squared plus y squared. Hold on. We have 1x squared here. X squared minus 2xy plus y squared. Oh, mistake. Why write y squared out there? It should be y squared minus 2xy plus x squared. Y squared minus 2xy plus x squared. Alright. So let's do this part again. We have x squared plus x squared, that's 2x squared. What about the y squared? Y squared plus y squared, that's 2y squared plus 2y squared. Negative 2x minus 2x, that's going to be minus 4xy, right, is equal to 4r squared. Alright, so let's rewrite this. 2x squared minus 4xy plus 2y squared equal 4r squared. Let us see how we can factorize this part. Right? Oh, let's divide everything by 2 first to simplify. We have x squared minus 2xy plus y squared is equal to 2r squared. Good. Remember the AC method. Ax squared plus bx plus c equals 0. Right? Or let's deal with the revision of the AC method over here. Just want to do a little revision of it, and then we'll come back to this. When you have a quadratic function, this is general form. When you're factorizing it, You multiply A by C to give AC. That's why I call it the AC method. You find two numbers that multiply to give you AC, and they add to give you B, and then you say A x squared at one end, C at the other end, and then in the middle say plus number 1 x plus number 2 x plus C equals 0. Then you group and factorize. In this case, AC method, say x is our variable here. We have A x squared plus bx plus C. Now, our A would be 1 because this is 1x squared, right? Our B, alright, let's write it as 1x squared plus negative 2y x plus y squared equal to r squared. Alright, so A is 1, B is negative 2y. Alright? So now, so remember, we're looking at y as just a number. So our A is 1, our B is negative 2y. If you multiply and to get AC, AC would be 1 times negative 2y is negative 2y. Alright. Now, suppose we think of the other part now. The two numbers must add to give B. The two numbers just multiply to give negative 2y. They must add to give AC is not negative 2y. My. AC is 1 times, I didn't write the C. C would be y squared. AC is 1 multiplied by y squared, which is y squared, right? It is the B that is negative 2y. The two numbers, they multiply to give y squared, and they add to give negative 2y. So let me make a note of that. We're going to find two numbers that add, when you add them, no, when that multiply, let's do the multiply first. That multiply to give y squared, and that add to give b, where b is negative 2y. Good. Which two numbers are those? Well, that being the case, we can try y and y, because y multiplied by y give you y squared. The problem is they don't multiply to give you, they don't add to give you negative 2y. They add to give you positive 2y. So let's try negative y and negative y. Negative y by negative y, it gives you y squared. Negative y plus negative y gives you negative 2y. So those are the numbers, right? Good. So now that we find the numbers, we will split up the middle part into those numbers. So you have 1x squared minus y minus y. Minus yx. Let's put the x there in front. Minus xy. If it was numbers, you would say the number then x. But since it's xy, generally just follow the pattern and put it in alphabetical order. Minus y times x minus y times x, right? Plus y squared equals 2r squared. Notice this negative 2y, is the same thing. Because negative, hold on. I say negative 2y. Yeah, time x, yeah. What I should circle is the whole negative 2xy. So you see, all of this is negative 2xy, you know. You just have to separated the 2y from the x. It's negative 2xy. So you see that? It is this. Negative xy plus negative xy is negative 2xy, right? Just want to highlight that. Remember, this here is the equation, which is a repeat of this equation. It's the same equation, alright? Alright, so this is what I have. Then you factorize them in groups. X outside this bracket, x minus y inside the bracket, minus x outside this bracket, and then minus y. Right, it would be y outside this bracket, and then x minus y inside the bracket, right? Equals 2r squared. You have to remember your factorization, and notice x times x give you x squared, and then x by y give you negative xy, then negative y by x give you negative xy, and negative y by y give you positive y squared. Factor out the x minus y now. We have x minus y. We have x minus y equals r squared. See that? Alright, so this means x minus y squared equals r squared. Right? X minus y squared would be r squared. So that is telling you that x minus y is really r. But anyway, find the square root. X minus y is equal to positive and negative square root of r squared, which is plus or minus r. So here now, negative y is equal to negative x plus or minus r. Or if you multiply both sides by negative 1, you get y is equal to x minus and plus r. But same thing as saying plus or minus r. Alright? So y is x plus r x minus r. So y is equal to x plus r and x minus r. So if you have the circles, right, have the radius here, so y is x plus r and x minus the radius r in this case. Alright? So that is what we have. Oh my, what about the 2? Oh no, mistake. The 2 is 2r squared, so the 2 was there. Yeah, I suspect something was wrong, you know. When you find the square root of both sides now, you find the square root of 2r squared. And this, you accidentally left out the 2 earlier. I didn't carry the 2 down. So, you see the square root of, let me write this clearer. This is square root of 2r squared. It's going to be square root of 2 times square root of r squared, which is r. So this now would be positive and negative. The square root of 2r. Right. Square square root of 2r. Because I was looking up here and see something is wrong somewhere now. Alright, so square root of 2 times r. Right. So y is equal to x plus or minus the square root of 2r. As it wouldn't be just r, it would be square root of 2r. So the square root of 2r is what we have here. So y is equal to x plus or minus square root of 2r in that case. Alright, so that's what we have there. I'm going to do a quick revision of this in the next video.